I'm going to talk about wet pipe sprinkler system. There are 4 types of sprinkler system as for NFPA 13, which is wet pipe system, dry pipe system, deluge, and pre-action system. Right. So most common the wet pipe system. It is almost around. It is used around 80 to 85% of the installation worldwide. But only it failed in the area where we have freezing temperature, where temperatures go below 0 degrees Celsius, minus 20, 30, and so on. We cannot use wet pipe system in those locations, right? Then we have the next option. We have to use dry pipe system, right? But dry pipe system is a little bit costly and also require higher maintenance. If we can also use wet pipe system along with antifreeze solutions, right? Normally, if you put antifreeze solutions, something like glycol and all, into waters, it will further goes minus 10 or minus 20 degrees Celsius, without any freezing and all. So either we use wet pipe system with antifreeze solution, or we have a dry pipe system option. The third one, we have deluge system. The meaning of deluge is flood, right? Means there is no closed sprinkler. All of the sprinkler is open, right? So when there is a fire, detection system detect the fire and it activates the deluge valve, right? So all water will come from all the system and to extinguish the fire. Last one, we have the pre-action system. It used where we have over water damage like art galleries, museum, library, and so on. So here we have a wet pipe sprinkler system general layout, right? General diagram. Wet pipe system normally consists of alarm check valve, OSY valve, fire department connection, main drain valve, flow switch, sprinkler, pipe hangers, and fittings. Right? So normally, this is our time point. From here, we are taking the connection to our wet pipe system, and then we have a main control valve. So to control the supply into the system. After that, we have a alarm check valve, right? And then we have a fire department connection here to supplement the water supply into the system. Below the fire department connection, we have a main drain valve, so drain the water for the maintenance, or if the system discharges water and after that we want to put it into the service, right? Here we have a water flow alarms. When water flows, there will be alarm from the mechanical alarm system. Then we have a riser, right? And all the way, this is our cross mains and then the branch line. Here is our sprinklers, right? This is all the sprinklers installed. It's a pendant sprinkler here. And we know that when there is a fire, from the fire goes to the sprinkler, it hit the bulb and the bulb fuse at a certain temperature. At the bottom, we have fire department inspector test valve, right? So inspector normally want to make sure he just open this valve and make sure what is the pressure and flow at this location. Also, he want to make sure when he opens this valve, after how many seconds there is sound, right? That flow switch detect the flow of the water. They want to make sure. They can use this one also for, discharge the water from the system in case of the maintenance. Then we have a wet pipe system here, right? A general layout of the wet pipe system. If you can see here, alarm check valve using Viking models, right? So this schematics, here is our main straight line. From here we have connected our system. This is our riser, we call it risers, right? Below the alarm check valve, we have a water supply control valve. We'll discuss that one in detail. And then we have an alarm check valve with 2 pressure gauges, one at the top and one at the bottoms, right? All the way from the alarm check valve, we have a connection going to a pressure switch, and also the same line is going to water motor alarm gong, right? When the flow begins, the water from this line will go to the pressure switch. Now pressure switch will activate it gives a signal to the panel. At the time, water motor alarm will activate, right? And then we have a fire department connection, which is used to supplement the water supply. Here we have this line for that purpose, right? In the right, we have a alarm check valve, right? If you can see the same 3D model, there is pressure gauge, one at the bottom, one at the top of the alarm check valve. Then we have a retard chamber here, right, to avoid the false alarm during the surges. And we have a pressure switch here at the top of the retard chamber. And then we have a water motor alarm. We'll discuss regarding all in detail, right? Just wait a moment. So now moving on to the components of alarm check valve, right? In the left, we have a pressure gauge, which is 2 times of the design pressure. Normally, the maximum design pressure of water-based fire protection system is 175 psi. Right? In most of the case, except a standpipe and a water mesh system, where may we have higher pressure than that. So the rating of these gauges should be at least 2 times of the design. So 175 is the maximum, multiplied by 2, we have 300 psi here, right? Even more than that one, right? More than that, or at least something around that one. It should not be less than that one. And then we have in the right, where we have a water motor alarm, right? It's a mechanical device activated by a flow of water. When water started flow, it will activate. And we need alarm when we have more than 20 sprinklers installed in a wet pipe system. So if we have more than 20 sprinklers, we need any kind of the alarm system, right? So here we have a mechanical alarm, right? And it needs minimum 5 psi for continuous alarm, right? And it will give a sound something around 90 dB to 100 dB decibels, right? So what is the continuous we have here, right? When the system activates, the water flow all the way from this pipeline, it will go to this alarm box and it will make sound, right? And when water flow from this one, the pressure switch also activated and it will give a signal to fire alarm control panel. So this is all about water motor alarm, right? We need where we have more than 20 sprinklers in the system. And then we have a retard chamber, right? You know, when the system is connected to a variable pressure source, something like a city connection, where we have pressure surges going higher sometimes, most of the time pressure going higher and down. So in that case, due to those pressure surges, there will be false alarm. So to avoid that false alarm, we need a retard chamber to just avoid any kind of false alarm in the system. So here in the left, we have a retard chamber in normal condition, and in the right, we have a retard chamber when we have high surges in the pressure. So we have high surges in the pressure, it will absorb all the surges and prevents false alarm, right? And the size of the retard chamber is something around 3 gallons in size, so that it is more than enough for the system. Then we have water flow alarm switches, right? In the left, we have a water flow alarm switch. It's activate alarm when the sprinkler system operates. So when system operated, right? When the flow begins, you can see here, right? When the flow begins, water all the way from the alarm check valve connected to this water flow alarm switch, it will give a signal to control panel. At the same time, the same line will go to the water motor alarm gong to activate the sound in the water motor alarm. So what is the need of this switch? This switch also may initiate signal to annunciator panel, trip to the municipal fire alarm box, or it give a signal to fire pump to start, right? It might give, once a sprinkler system activate, it gives signal to the municipal fire department also. They should come to the site within 20 minutes as per the design philosophy or the local jurisdiction requirement, right? In the right, we have a drain valve. Here we have a drain valve, right? So the size of the drain valve we have as per 8.16.2.4.2 of NFPA 13 is for up to 2 inch of the alarm check valve, we need at least a 20 mm size of the drain valve. If it is 2.5 inch to 3.5 inch, it is around 32 mm, and 4 inch and larger, we need 2 inch drain valve, right? So normally we need drain valve to discharge water in case of the maintenance, or once the system activate, we have to remove water from the system. We need a drain valve to drain the complete system. So until now we were discussed about the component of the alarm check valve. So we have also fire department connection with the wet pipe system, right? Not with the alarm check valve, but with the wet pipe system. So we have to discuss this one also, right? Right. This is our fire department. This is from main line. This header is going to the valve room, to the riser of the sprinkler system. We have a check valves, means water will go only in forward direction. And this is a connection to the fire department connection. Similarly, like this one, 2.5 inch into 4 inch connection type. So the purpose of fire department connection is to supplement the water supply, right? Not necessarily to provide the entire system demand. We just want to supplement the water supply if we need in case of the fire. So fire department connection for all building required. It's required for all building except some of the case where the building is in remote areas. The first one, building is in remote area and are inaccessible to fire department trucks or the steam. The second one, it with the deluge system. When the system is very large and it is beyond the pumping capacity of the fire department team. And the last one we have single story building not exceeding 185 square meter. So if your building is less than 185 square meter, we can exclude the fire department connection. So these are the three requirements: remote locations, large deluge system, and area below 185 square meter. Then we have a main control valve, right? We have OSY type gate valve and we have butterfly valve. We saw the main control valve just below the alarm check valve to control the supply lines, right? To close or open the valve. This control valve need to be supervised and connected to the fire alarm panel. Here we have a tamper switch. This tamper switch is connected to the fire alarm panel. If someone is closing it by this handle, it will give a signal as a supervisory signal that the valve is open or valve is semi-closed, something like that. We have to be supervised on, because most of the failure of the sprinkler system is because of the closure of the control valve. You are doing maintenance. After the maintenance, you forget to open the valve, right? In that case, if there is a fire, if the system is not going to control the fire, we have to be careful regarding that one. In the right, we have a butterfly valve. It's also a control valve, and the function is the same to control the supply, but the butterfly valves need less space compared to the OSY type gate valve. So if we have a space limitation, we can go with the butterfly valve. Now, if you can see the yellow one, the yellow flapper here in the butterfly valve, it is a indicating type, means the valve is open or closed. Now, it is perpendicular to this pipe, right? It is perpendicular to this pipe. It means the valve is closed. If it is parallel to the pipe, it means valve is open, right? So, if you can see the wire here, means it is supervised and it is connected to the fire alarm control panel. If someone is closing, it will give a signal. Last point with the control valve, you are not allowed to close the valve within 5 seconds, because within 5 seconds, if you are closing the valve, it will cause water hammers and damaging the pipe, and also we have to make sure that the valve is not closed within 5 seconds. And then the maximum area protection by wet pipe system, right? The maximum floor area protected by one riser. So it's based on the types of the hazards. If you want to know more about the hazard classification and all, I recommend you guys to go to my other video in the link, which is hazard classification, right? So you just look at that video and then come to this video to understand more regarding those requirements. Now coming to the area limitation. For the light hazard, the maximum area should be protected by one riser is 5200 square feet, and same for the ordinary hazard. But if we are going for the extra hazard, we have a limitation of 40,000 square feet, and if it is high pile storage defined as for 3.9.1.16 of NFPA 13, we have 40,000 square feet. This is all about the protection areas. Maybe in the future I'm going to make a video regarding the design condition of the sprinkler system, so I will cover this part there in detail. So stay updated with my page. Okay, here comes to the end of this module. If you have any doubt, comment, suggestion, you can connect me through the LinkedIn, or you can follow my page on Facebook, and I will be happy to assist you there. So take care guys, thank you, and stay safe. See you next time. Bye bye.